Have you ever seen a sculpture that moves? Today, I'm taking you behind the scenes of a unique project, a kinetic sculpture inspired by one of Europe's most spectacular works. Hello everyone, and welcome to this new video on the Free Dreams 106 channel. Today I'm bringing you something different from the usual. No filaments, no printers, no software, but rather a 3D printed kinetic sculpture that literally drove me crazy with excitement. But be careful, because I didn't print it myself, and soon you'll find out who helped me bring this project to life. In this video, I'll tell you everything, from the inspiration taken from an incredible journey to the design, printing, and the final result. Ready to discover how a moving sculpture is born? So let's cut to the chase and get started right away. The moment. What is a kinetic sculpture? In short, it's a sculpture that moves. It is not static, but has parts that come to life thanks to motors, gears, or even just the force of gravity. Look at these, for example. Aren't they hypnotic? It's not a new concept of sculpture. In fact, there are several examples created by great artists. However, they are not very widespread, perhaps because they are more complex to create than classic static sculptures, obviously. But in my opinion, they are pure magic and have an extra edge. Would you like to have one in your home? Write it down here in the comments. And do you know where my obsession with kinetic sculptures started? From a trip to Prague. Prague is a wonderful city with numerous monuments to visit, but there is one thing in particular that left me speechless: the Kafka Head, a gigantic sculpture by the artist David Cerny. It's a stunning work that comes to life thanks to a series of motors and a light show. And in person, it's truly a spectacle. It moves, it transforms, it almost seems alive. So I said to myself, why not try to bring a bit of that magic to my desk? So I immediately got to work. And started thinking about a mechanism that could be 3D printed and create a fascinating movement, even if only on a small scale. Kafka's Head uses fairly complex motors and gears. I wanted something simpler, but that still had that wow effect. So the first challenge was to make the slices of the head rotate in a smooth and hypnotic way. I sketched out some ideas, tested them, and finally found a solution. Once I found the right system, I immediately moved on to CAD modeling to bring my sculpture to life. I started with the heart of the project, which is the internal mechanism. From there, I then built everything else: the base, the head, and the system that sets everything in motion. This is the manual version someday, but I'm already thinking about a motorized version with a few more surprises. Let me know in the comments below if you would like to see an upgrade of this sculpture. To operate the sculpture, I decided to use bevel gears, better known as bevel gears. These gears are truly fascinating. In fact, unlike classic ones that transfer movement between parallel axes, bevel gears allow rotation to be transmitted even between perpendicular axes. This system allowed me to create a compact and functional base, where each turn of the knob translates into precise movement of the various sections of the sculpture. The benefit of my bevel gears is that despite their simplicity, they manage to make the movement smooth and silent. I wanted the movement to be really interesting. Obviously, I couldn't replicate the sophisticated system of Kafka's Head, but I found a way to make each rotation unique. I created a system with 6 different positions for the gear that moves each slice of the head. Thus, the sculpture is customizable and each movement is different from the previous one. And the subject, one of the main elements of the sculpture, of course. Well, I made several attempts, but for this first version, I chose one of my idols, Leonardo da Vinci. I found the bust online and then adapted it into a low poly version that I thought matched well with this type of sculpture. However, for the next version, I already have something special in mind, so subscribe to the channel to not miss the upcoming videos. But here's the surprising part. I didn't print this sculpture myself. In fact, to realize this project, I turned to JLC 3DP. JLC 3DP is the branch of the company JLC PCB dedicated to 3D printing. This company is quite unique because it offers a whole range of manufacturing services, perfect for our needs as makers. JLC 3DP is an online service that allows you to order 3D printed parts directly from their website with an instant quote and a super easy to use interface, which also lets you manage your orders from home very easily. But why would someone who has a 3D printer at home use this service? Well, because JLC 3DP not only offers printing, filament, and LCD resin with the most classic materials, but it also gives us the option to choose from different types of manufacturing, including industrial 3D printing like SLS, MJF, or even SLM, with which we can order 3D printed metal parts. Honestly, it's a very convenient service. They produce parts super quickly, even in just 24 hours, with delivery in just 2 days. You can order parts for very low prices, starting from just 30 cents. And if you use the link I leave in the description, you can get up to $70 off your first order. I would say it's a great deal. So take a look at their website, even just out of curiosity, because they really offer a lot of super interesting material. But hold on a moment. Before printing everything, one crucial thing: test the mechanisms. I printed a prototype of the gears to make sure everything worked perfectly. I confess that I could spend hours turning this model because it's so relaxing and satisfying. Anyway, when everything runs smoothly, you move on to the actual printing. Well, now that we have all the pieces, we can start with the assembly. And voila, the sculpture is ready. Transparent Leonardo is spectacular in my opinion, and as you can see, Oliver used different materials for this project. The head and the internal mechanism were printed in transparent resin using SLA technology, while the base and gears were made in SLS nylon, which, in my opinion, looks like cast iron. It's the first time I use an SLS printed piece in my projects, and I am really thrilled with the result. I honestly would recommend you try it if you have to undertake an important project, because it's really worth it. But the highlight, gentlemen, is the knob with my logo, because this was printed in steel with an SLM printer. Amazing. For me, metal printing is one of the most fascinating things ever, and I am super excited about the idea of being able to include a 3D printed metal piece in my project. And now finally, the moment I've been eagerly waiting for weeks. All that's left is to see if our hard work has paid off.